Hey class, today we're going to talk about scatterplots and lines of best fit. So essentially we're going to talk about what happens when the data isn't perfect, which is real life. As a matter of fact, in real life, things never look as neat as the tables we give you in math. Look at it, everything lines up perfectly. No, real life is more like this. The data tends to be a little bit off here and there and a little bit scattered. So what do? We need to find the best possible fit. We have to find what we call the line of best fit. So what are scatter plots? What is all this stuff? Think of it this way. Real life isn't always neat. Data gets messed up, it goes all over the place. And we have to find our best case scenario. That's our line of best fit. Where would the line be if all of our data lined up perfectly? What would it be if everything came out exactly the way we wanted it to? That's our line of best fit. Data doesn't always behave that way. So how accurate is a line of best fit? Truth of the matter is, just like we say give or take a little, there's an error here, an error there. With data, the same thing happens. We call it the correlation coefficient. And a correlation coefficient tells us how accurate our line of best fit is. So let's get ready to take some notes on some definitions. Scatter plots are ways of relating two different types of data. So for example, we have foreclosures versus household units in that bottom left corner. The scatter plots are all the red dots. That's all the data we actually collected. It's mostly going uphill, so we say it has a positive correlation. That black line is what we call the line of best fit. If everything was perfect, it would be on that line. It has a positive slope. Look at the next one. It has a negative correlation because it mostly goes downhill. In the third one, the data is all over the map. It's so scattered that there's no way we could possibly relate percentage of college educated to pet owners. It has no correlation. This does not connect the dot, guys. The line goes through the middle and may not hit any of the points at all. It may hit one, it may hit none. That's where the correlation coefficient comes in. Get ready to take some notes. So what do? Take a look at this data. It relates time to the height of water. Say I was filling in my bathtub and I wanted to see if the time related in some way to the height of the water in my bathtub. I go out, I do my measurements, I collect my data. Here it is. So what do we do with the data? We took data, we went into the bathtub, we measured how high the water got over a period of time. Now we have to actually construct a graph or a scatter plot. Has to have a title, the height of water in my bathtub. Has to have labels on each of the axes, time in seconds here for X. You don't just label it X and Y. It has to have labels. And height in inches. And it has to have a unit measurement. So each one of my tick marks here is 1 second. And you can see that. Each one of mine here on the y-axis is 1 inch. Again, I put all the numbers in. Now, I have a pretty good data graph. I take my table. We said that when it was 2 seconds, it was at a height of 7 inches. So I go 2, I go 7. There's my first point. Here's 4 and 8. I believe here we go 13 and 6, etc., etc., etc. These are all my data points. This one, this one, this one, that one, and that one. They do not form a straight line. It's a scatter plot. So the next step then is to take a ruler. In this case, I took my, it's a straight edge. I took my straight edge and I did a best guess. Basically, when we do this by hand, we're guessing and we're doing our best possible guess, which is why we don't often do this by hand. We often do this on a calculator or a computer. But I took my straight edge, I eyeballed it, tried to get a line that was through the middle as best I could, and that's what I got. This is my line of best fit, in other words, my best guess, of where the data would be. I use this line of best fit to make guesses or predictions really educated guesses onto where my data would be later on in the trial or later on in the experiment. Now that I have my plots and my line, now it's time to write an equation of the trend line. Notice it's an equation of a line, so it's going to be in the form of y equals mx plus b, but it's not a regular line, it's a trend line. That's how I keep myself honest. This is a best guess. It's not the actual straight line. So, I need a couple of points. I can pick any point on my line. I'm not picking the scatter plot points. No, I'm picking lines on my line of best fit. I pick this point and this point. Now I have to go down and see where on the x it falls, where on the y it falls to give myself some coordinates. This one, when I go down, it's 2. When I go to the side, it's 6, so that's my point 26. This one, when I go down, it's 8. When I go to the side, it's 17, so this is my point 817. I use my slope formula, y2 minus y1, x2 minus x1. I put in my data, 8, 17, 8, 17. 2, 6, 2, 6. That gives me a slope of the trend line of 4/3. Always simplify, never turn it into a mixed number. Leave it as an improper. Now step 2, use my point slope form, y minus y1 equals m times x minus x1, and pick one of the 2 points. I picked this one because I don't like dealing with 17. It's just personal preference. 2 and 6 are just nicer numbers to me. So I insert my slope and my coordinate points, clean it up, and now I have an equation that says y equals 3/2 x plus 10/3. I can use this. This is the rule of my trend. I can use this to figure out what would happen if x was 27, if x was 28. It is a guess though. If x was 28, I can use this equation to find what y would be, and that would be my guess, my best guess of where the data would be. Because this is a trend line, we can say the actual data will be maybe a little above, maybe a little below the point that this line gives us. It'll be close. How close? That's where the correlation coefficient comes in. The correlation coefficient tells us how close we think our line of best fit is to the actual data. If it's really close to 0, then we have very little confidence in the fact that the actual data will be close and not too far away from the line that we drew. If it's close to -1, if it's going downhill, or +1 if it's going uphill, then we're really certain that it's going to be really close to the line that we drew. For example, if I have a correlation coefficient, we use the variable r. So if we have an r value of 9/10, that means we're almost 90% sure that that dot that represents the actual data is going to be super close, almost on top of the line that we drew. If we have an r value or correlation coefficient value that is really close to 0, so maybe 0.000005, that's really close to 0. We have almost no confidence. It's less than 1%, it's less than 0.5%, it's less than 0.75%. It's really small percentage. We have very little confidence that that actual value is going to be really close to that line. So here's how you do it by hand. What do you do with the calculator? First thing you need to do is turn on the diagnostic capabilities on your calculator. You're going to hit the second button, you're going to hit the catalog button. That's your 0. This is going to let you go through the catalog of the calculator and turn on the diagnostic functions. Scroll down, go all the way to the D, select diagnostic on, enter, enter again. Now it's ready to give you a correlation coefficient value R and a line of best fit. Hit the stat button, go to list 1, put in all of your X values under list 1. Now go over, put in all of your Y values under list 2. Now your calculator knows what your x values are and what your y values are, and it can graph them. However, you need to make sure that the window you are using is the right size. If it's not the right size, you won't see all of your points, or your points will be unusable. So hit second, hit Scatterplot, which is your y. Make sure that you have the first plot on, the first type of plot, which is a scatter plot. X list should be L1, Y list should be L2, the mark you want. It's telling your graph what kind of graph you want. It's telling your graph function what you want it to look like. Hit the window, change your maximums and minimums to include all of your data. I'm about to make a mistake. I put it in 112 for my X max. I put in 24 for my Y max. Look at the type of graph that it's going to give me. It's too squished together because my y-axis is too big. Go back, I'm going to correct it. Now I'm going to set my y-max to 12. That's going to show every single one of my data points. Now I have a scatter plot. Next step is we need to find our R and we need to find our line of best fit. To do that, go into your list stat mode, go over to your calculator and highlight line reg AX plus B. That's telling it that you want it to give you a line of best fit with an R value, coefficient correlation value, or correlation coefficient value. Make sure that you highlight list 1 and list 2. So second, L1 is button 1, comma, L2 button 2. Hit enter. There's your R value. There's your Y equals AX plus B.